All right, so now, again, the first thing that we're looking at is if we're going to graph the linear equations using x and y intercepts, you actually have to know what they are. And the y-intercept, well, that's the special one. We've done that a bunch. But that is, again, just kind of recapping, is that that is where the line hits the y-axis. Now, there's something also very special about that is the x, and this is something we looked at when we were finding the equation using a table. The x is always equal to 0 at that spot where you have where your line hits the y-axis. And in a similar way, your x-intercept is where the line hits the x-axis. And the special thing about the y-intercept is that the y is equal to 0. And that's an important fact that we're going to use. All right, so when I'm graphing y equals 3x plus 2y minus 12 equals 0. Again, this is the equation of a line, but it looks different. And here's what we're going to do. We're going to, first of all, we'll find the y-intercept over here. All right, because if I find 2 points, then I can graph, just like we did before, where we were able to use actually more than 2 points, but you can need at least 2. And again, though, x is equal to 0 for the y-intercept. So I'm going to take the equation of my line here, 3x. Here, I'm going to write it down again here first. So I got 3x plus 2y minus 12 equals 0. All right, now again, with this equation, the x is equal to 0. So I'm going to have 3 times 0 plus 2y minus 12 equals 0. All right, because I'm trying to find the y-intercept, I plugged in 0 for x. Now this term here, 3 times 0, well, that's 0, so it just disappears. So now we have an equation where it's 2y minus 12 equals 0. All right, so I can move that negative 12 over to the other side. And again, when it changes sides, it changes sign. So now I have a positive 12. All right, solving, I can divide by my numerical coefficient, which again is a value under or in front of our variable. And so what we end up with is those 2's divide each other out. So we get y equals 12 divided by 2 is 6. And so our y-intercept then is the point. 0 is in for our x, and our y value is 6. So there is 1 point on our graph. All right, now we need another one. So I'm going to go over to this side here, and I'm going to find my x-intercept. And again, the key thing with the x-intercept is that the y is equal to 0. All right, so once again, I'm going to use my equation, all right, which is, again, our 3x plus 2y minus 12 equals 0. So I'm going to write that down again. 3x plus 2y minus 12 equals 0. All right, but this time where there's a y, I'm going to plug in a 0. So I'm going to have 3x plus 2 times 0 minus 12 equals 0. Make that a little bit bigger. There we go. All right, so again, this here, 2 times 0 is equal to 0, so this basically disappears. And so what we have is an equation now where we got 3x minus 12 equals 0. And I solved this equation by moving this minus 12 over to the other side. And again, switches sides, switches sign, so it's going to become a positive 12. I'm going to divide by my numerical coefficient. All right, so those 3's divide each other out. And so what we end up with is x is equal to, well, 12 divided by 3 is 4. And so our other point is the 4 is our x value. And again, at your x-intercept, the y is always 0. And so now we have 2 points. So now I'm going to graph this because that's the whole point here. 0, 6, which means don't go left or right at all, but go up 1, 2, 3, 4, 5, 6. There's 1 point. Now I'm going to graph my x-intercept, which is 4. 1, 2, 3, 4 over, 0 up or down. There's my other point. And now I can draw myself a line through these 2 points, so all the way through. And there is the equation of our line, or the graph of our line. We found the y-intercepts and we found the x-intercepts. So this is a different way to graph the equation of a line because we're not using the slope. We are still using the y-intercept, but we're not using the slope now. We're using the x-intercept and the y-intercept. And it's again because our equation, it looks different. It's been changed a bit. Any questions at all? I'll look on the chat here to see if there's any questions. I don't see anything. Okay. All right. So let's see. I'm going to do example. Let's see here. Number 3 here. Example 3. I'm going to do 1, 3, and let's see here. 4. 1, 3, and 4. All right. So again, I'm going to graph this using my x and y intercepts. So I'm going to find my y-intercept first. And again, the key here is that our x value is equal to 0. All right. And so I have the equation of my line up there. So it's 6, but my x value is 0. So I'm going to plug it in right away. I'm going to skip a step there that I did last time. Minus 3y. Here. Oops. Give a space. 3y. This time we have equals negative 24. All right, and again, what is happening is 6 times 0 is 0, so this thing is basically disappearing. And so the equation is just, I'm going to rewrite it here, negative 3y equals negative 24. And so I want to get y by itself, so I'm going to divide by my numerical coefficient here, which is negative 3. What I do to one side, I got to do to the other. All right. Those negative 3's divide each other out. And so what we're left with is that y is equal to, let's see here, negative 24 divided by negative 3. A negative divided by negative is positive. It's going to be a positive 8. And so the point that we're going to graph is the x value is always 0 for the y-intercept. And this time it looks like it hits at 8. So the point is 0, 8. There's 1 point. Back over on the other side here to find the x-intercept. And again, the key part there is that the y is equal to 0. All right. And so I'm going to substitute that known fact into my equation. So I have 6x minus 3. But again, my y value is 0. So I'm going to plug that in. Equals to negative 24. All right, and this is common here. 3 times 0 is 0. So this is just going to disappear for us. And so now my equation simplifies down to 6x equals negative 24. All right, still need to solve. So I'm going to divide by my numerical coefficient. All right, and let's see here. Let's see, x is equal to negative 24 divided by 6. It's going to be a negative because I have a negative divided by a positive, and I believe it's going to be negative 4. And so the point is our x value is negative 4, but again, because it's our x-intercept, the y-coordinate is 0. All right, and now I can plot my points. So let's see here. My y-intercept is 0, 8. So 0, don't go left or right. And then we go up 1, 2, 3, 4, 5, 6, 7, 8. Go. Our y-intercept is negative 4, 0. So that means go 4 left. 1, 2, 3, 4. Don't go up or down at all. That's why it's on the x-axis. And now I've got my 2 points. So I can graph my line. Let's see here. Line it up. It's terrible. Let's see, do a good one here. I'll start here instead. There we go, all the way through to graph my line. And there we go. Again, finding 2 points to graph our line. Any questions at all? Okay. change it up a little bit here. Like I said, I'm going to do example, 4? There we go. Now, this one's a little different here. I got 5 halves x minus y equals 5. And I want to find it, the x and y intercepts. Here's what I'm going to do first, though. I'm going to rewrite this equation. Because, again, the one thing I don't like is fractions. The only time I write a fraction out without figuring it out is slope. But we're not dealing with slope here. We're just dealing with x and y intercepts. So I'm going to rewrite this equation. I get my calculator out here. I do 5 divided by 2 because, again, a fraction is just a divided by question that isn't done yet. And so I go 5 divided by 2. I get 2.5x. Minus y, well, really, that I could write that as minus 1y. Same thing, equals 5. So all I'm doing there is rewriting the equation just so I can use it. All right. But again, I'm going to do the same thing I did before. I'm going to find my y-intercept here first. And it doesn't matter which order you do. I just know because we use the y-intercept the most, I always tend to do it first. But again, I do know what the y-intercept, my x value is going to be 0. All right, so now I'm going to use this equation here, the simplified version of it. I'm going to plug in x is 0, so I got 2.5 times x. Well, this time our x is 0, so plug that in. Minus 1y equals 5. And as usual, I check out here. This part here, 2.5 times 0 is 0, so that's just going to disappear. All right, and so our equation is going to simplify down to minus 1y equals 5. All right, but again, I got to divide by my numerical coefficient here, which is a minus 1. And what I do to one side, I do to the other. And then my y value, let's see here. I've got 5 divided by negative 1. Positive divided by negative is going to give me a negative. So I get negative 5, which means my point that I'm going to graph, again, the x value is always 0 at the y-intercept. And it looks like the y value is negative 5. So there's one point. All right. Back over again, we need 2 points to graph this line. So the other one is the x-intercept. And again, the key thing here is the y value is always equal to 0. There we go. And so I'm going to use this equation here. Once again, my simplified version. I'm going to plug in a y value of 0. So I'm going to have 2.5x. Let's see here, minus 1. But my y value is 0, so I'll put that in there, equals 5. All right, but again, right here, negative 1 times 0 is 0, so that's going to disappear for me. So what I got is 2.5x is equal to 5. And again, I want to get my numerical divide by my numerical coefficient, which is the 2.5. What I do to one side, I do to the other. All right, so these 2.5s divide each other out. And let's see here. So I get my calculator because I got a decimal here. I got a positive divided by a positive. 5 divided by 2.5 is 2. All right, and that means my x-intercept is 2. And again, at the x-intercept, the y-coordinate is always 0. All right, I got my 2 points. Time to plot them on my graph. All right, so my first point to plot is 0, negative 5. So that means I'm going to go down 1, 2, 3, 4, 5. There's my y-intercept there at negative 5. My x-intercept is 2, 0. So let's see, 2 zeros right there. All right, and again, I'm going to draw in my line because all I need to do is connect the dots, 2 points, all the way through because, again, the line continues the pattern. And there we go. And that is how you graph x and y intercepts. Let's see here.